In surveying, often you are required to carry out chain surveying of a site that is irregularly shaped and also find out its area. Do you know, once you have the chain survey data of such sites, you can compute their area. You can compute areas from chain survey data by applying different methods. Let's find out what those methods are in this module, Computation of Areas from Chain Survey Data. Welcome. After completing this module, you will be able to explain the steps involved in field data entry and cross-staff survey for estimation of areas and find the area by using chain and offsets. The first of these methods is the average offset method. With this method, you can compute the areas of regions with irregular boundaries made of straight lines by taking perpendicular offsets. First, run a long line from one end of the area to the other. Then, divide the line into equal chainages or distances. Measure the equal distances with a chain or tape and mark equal lengths by driving arrows into the ground. To the extent possible, try and keep the chainages equal. Then, take the perpendicular offsets by placing the cross staff at equal chainages. The distances you obtain in this way are called ordinates. Ensure that you take the offsets in such a way that the end of one ordinate is joined to the other by a straight line of the irregular boundary. Once you have the required number of offsets in the area, you can calculate the area with the formula A is equal to the sum of all offset distances divided by the number of the offsets multiplied with D, where A is the area to be calculated and D is the distance or the chainage. To follow the mid-ordinate method, you must draw ordinates at each of the points of division of the baseline. To obtain the required area, multiply the average of these ordinates with the length of the baseline. For example, in this diagram, the area is the product of the sum of all the 8 ordinates divided by the number of equal divisions of the baseline plus 1 and the length of the baseline. The trapezoidal rule is applied in the case of areas where each part is assumed to be a trapezoid. The trapezoidal rule can be stated as follows. To the sum of first and last ordinates, add twice the sum of intermediate points. Multiply the total sum thus obtained by the common distance between the ordinates. 1/2 of this product gives the required area. For example, in this diagram, The area can be calculated as the product of half of the sum of the lengths of the offsets O0 and O8 added to twice the sum of the intermediate offsets O1 to O7 and the value of L divided by N, where L is the length of the baseline and N is the number of offsets. Simpson's rule is applied in areas where the boundary lines are like curves and arcs. The rule can be stated as follows. To the sum of the first and last ordinates, add 4 times the sum of the even ordinates and 2 times the sum of the odd ordinates. This sum, multiplied with 1/3 of the common interval between the ordinates, gives the area. As the results obtained by using Simpson's rule are more accurate, it is used when greater accuracy is required. If trapezoidal and Simpson's rule are to be applied, then note that the interval between successive ordinates must be uniform throughout the length of the baseline. If the interval is not the same, divide the baseline into different sections, each having the same interval. Calculate the areas of each section separately and add them up to get the required area. In this module, you have learnt the steps involved in field data entry and cross-staff survey for estimation of areas, and also to find the area by using chain and offsets. In the average offset method, the area is computed by dividing the baseline into equal chainages and taking perpendicular offsets by placing the cross-staff at equal chainages. In the mid-ordinate method, ordinates drawn at each point of division of the baseline are used to compute the area. In the trapezoidal rule, this formula is applied to compute the area. Similarly, this is the formula to be used for computation of area by the Simpson's rule.